Okay, hello. I'm actually wearing my PyTexas 2020 t-shirt. I've never been to PyTexas. That's because there was no PyTexas 2020. It was canceled. I still got the shirt. So this is my first PyTexas. But it's not my first time in Python. I think I started in 2003, something like that, back when I was a professor. This is an Anaconda slot, and I do work at Anaconda, but I'm going to try to distinguish 3 different hats that I wear. One is a Python user, so it's 4 hats. Python user, and then Anaconda employee, they pay my bills. Here I'm talking about a project called PyViz. PyViz is meant to be an objective overview of Python libraries for data visualization. And then I have my own team's work called HoloViz. That's totally separate. If I'm putting my HoloViz hat on, I say to everyone, use HoloViz, it's the best thing ever. But then I take that hat off, and this talk is about PyViz, where HoloViz is one of hundreds of other options. And the great thing and the horrible thing about Python, well, first stop. How many people have any sort of data that they use with Python? So it's 3/4 data-y audience. All right, so the great thing about Python and the horrible thing is that it has very many visualization tools. If you go over to R, it is very clear which visualization tools to choose. Python, it's not nearly so clear. And there are so many that I have not tried them, and I am pretty sure that no one in the world has tried 90% of them. I think people might be getting up to 25%, one person who's tried more than that. The thing is that choosing the wrong one will give you very bad results. And so how can you make sense of them? This is a sense-making talk. I'm trying to help you navigate a landscape. I've been around since there was one Python library for visualization, and now there are so many that it needs a lot of work. And so you can visit pyviz.org, or you can go to that QR code. It'll be at the end of the talk as well. The QR code sends you to this set of slides. Everything in the slides is clickable, or if I remember to anyway, it's clickable so you can find out where it came from if you saw something that was interesting. So pyviz.org, number 1, the main thing it does is list every tool I've ever encountered or that anyone has stumbled across PyViz has encountered. So if you see a tool that's not on there, please open a PR. It'll be on there the next day. And it also has overviews. There are overviews that discuss, compare this library or this library. Usually an overview has maybe 5 libraries in it. There's nothing that overviews everything, that tries to explain everything. So this talk is trying to explain everything, but obviously not in very much detail. Oh, and I put this here, when it's my personal opinion, I put it in italics in this talk. So I've tried to separate. I'm pretty sure this is true for everyone in the world versus this is how I see things. So this is what's the current contents of PyViz. I grabbed this list yesterday. It's 175 tools. There's one category down here that is easy to ignore. These are ones that have not been updated in years, or the author said, don't use this. I don't use this. You should not use this. So if you find yourself using this, you should ask why. And if you see an article that tells you to use one of these, that article is wrong. It just is. So that's the easy category. The rest, how do you want to just randomly choose one of these and try to plot your data? It's not going to be a good idea. You could just choose matplotlib. That's the easy answer, because matplotlib does so much. It's not the right answer for every problem, though. So that's the key thing to work on here. How do you figure out if it's not matplotlib? What do you do? So the way I've tried to understand that is that I categorized all the tools in my head. A subset of those categorizations are actually present on pyviz.org. Actually, I'll just show you pyviz.org so you see what I mean. If you click on the All Tools at pyviz.org, it'll show some categorizations that I did, or that people I work with did, and we worked this together. So I split them into some categories, such as core. The 3 in this one, lots of other tools build on that. And when you know a tool builds on matplotlib, you can immediately assume lots of things. Oh, I can export to PDF. Of course you can. It's built on matplotlib. That's not true for many other tools, but if you know what it's built on. And so there's this key little category here. If it's built on matplotlib right there, you know it. So this is a great way to at least C, if you know a tool, what's the main technology it's using? So this shows some basic categories, and then they're sorted by popularity. I don't know what else to sort them by. You'll see that matplotlib is the most popular. This little gray bar is annoying. There's no funding for PyViz, so we don't have any special API keys or anything. It's just hitting public services. And so when it's building these badges, sometimes it fails. But they are in order, so the most popular in each category is on the top. Anyway, you can explore all that after this talk. And please, if you spot any, make a PR. But this talk will try to get you some understanding about the whole landscape. What's available, and how do I know if that's right for me? Or not even for me, for my particular problem that I'm facing today. So the ways I've broken down are, there's like 7 of them here. I won't read these. I'll just go through them one by one in the talk. So the first is InfoViz versus SciViz. This terminology comes from IEEE. They have a track that is information visualization and a track that is scientific visualization. And to most people, those terms sound the same. I mean, it's science-y, whatever. What it means is, the quick trick is, does it have axes, or must it have axes? If you're on InfoViz, it must have axes, because you have no idea what's on X or Y. If it's displacement versus volume, how would you know that unless it had axes? But on the right, SciViz, SciViz is focused on things embedded in the real world. So usually they're 3D, 4D. It might be a 2D view of it, but it's something where you don't necessarily need axes. You know how big a head is. You know what that is left to right. You can see which way is front and up. So that's SciViz. It's things embedded in the real world, but usually with extra dimensions overlaid on top. Here, there's one that has axes. Those are unusual in SciViz talks or SciViz presentations. But most people, when they think of plotting, they think of this. But then they see these. Oh, this is cool. This is amazing. It's probably not relevant. You already know if it's relevant. You're working in that area. So simulating meshes to understand a jet engine or things like that are going to be over there. Most people are in InfoViz. And historically, in Python, these tools have almost no overlap. So a tool that's good for SciViz does very, very, very poor support for InfoViz. Sometimes, look, it added axes, yes. You look at them, the axes are not good. They're pixelated, they're not anti-alias, it's a mess. But they're happy to have them over here. But if you try to do 3D in one of these tools, it's really bad usually. So you really need to know where you are. Super important, but you're not going to accidentally end over here usually. You're just going to be jealous of it because you're over here. All right, the next big way that you figure out, is this tool even relevant to me, is what does this tool plot? And the standard typical thing is a statistical plot. A scatter plot, a bar chart, the sort of thing you can do in Excel, that would be a statistical plot. Most InfoViz tools will do that. A few, are suited to array data. So if you're working with satellite imagery or biology, microscopes, most tools will not handle those well. Only a few will. So you need to make sure that you're using the right ones. In almost everything, matplotlib will do almost everything here. So just assume that's true. But for most other ones, you need specialized tools. If you handle image data, you need specialized tools. If you handle network data, specialized tools for geodata. As long as you don't need any of these 3 things, you have a lot of options. So that's good and bad. A lot to choose from, but it kind of doesn't matter a lot of the time. All right, another is data size. Most InfoViz tools were written a while back when you were glad to have 1,000 points because every one of those took you a day to get. So that's where it came from. I mean, data visualization was starting in 1700s, 1800s. Like, it was an amazing achievement to have 100 data points. And these tools were written with that in mind, not written in the 1700s, but 1970s, same thing, a long time ago when people didn't have much data. And they have a lot of assumptions baked in about how you render data. For instance, if you render data and each data point has a specific shape, well, that only works when there are a few of them. Because what if this is 3 times as many? It's just going to be a solid block of blue. That's kind of pointless. It doesn't show you anything. Other tools, this is where I should have well, Data Shader is in italics. Data Shader is a project from my lab. That's taking the opposite approach. What if you had infinite data? What would you do? Because if you have infinite data in HoloViz tool, eventually your screen is black. Just like if there are infinite stars in the universe, the sky should be white. There's some paradox on that or something. But the data version of it is that eventually enough data will overwhelm all of your ways of approaching data unless you assume the opposite, which you're looking for the density of data rather than individual data. So if you have big data, don't just subset it and say, well, that's all you can do because the screen would be black or blue. No, there are tools that will let you see all of the data, all of the detail. All right, another big choice is, where is this data going to go? Where's this visualization going to show up? Do I render an image and then put it into a PowerPoint? Okay, a lot of tools will do that. Matplotlib is really, really good at that. But what if you're building an app, or you just want to share something on your website and you want people to be able to hover, you want to be able to explore, dive in? That's a whole other category of tools. Very little overlap. The tools that are good at this are not great at doing publication quality PDFs or SVGs. I mean, they can do it. You have to struggle a little bit. Another case of very little overlap between these two camps. And very little overlap between those two camps and this one, which is when you're building a native app, like a Windows app or a Linux app or a Mac app, where you download it and it installs in your operating system. You have native window cooling. Again, Matplotlib can do that. Very few others can. Most of the world is biased towards these other categories now. So the tools in this category tend to be very old. Another choice is esoteric, but it's going to have a big impact on your life. If you have many tools that do the types of plots you want to do and the right type of output, then you can start to be picky. I want one that's concise, and it is built around the way my brain works. You're lucky if you get to make that choice. But if you do, there are a lot of options, a lot of different APIs, a lot of different levels of verbosity. And the concise ones, like the pandas.plot, it's one-liner for a plot. It's great. But if you need a lot of control, you struggle with that. And then others, the Matplotlib object-oriented interface, even for the simplest plot, is already kind of verbose, and it gets more and more verbose, but a lot of control. So you get some choice there. And then you have a family of libraries that are trying to be declarative, not plot this here, but I'm describing my data, and then you can use it in a lot of different ways. So it's hard to appreciate that from one slide. You're never going to get it. But be aware there are multiple philosophies of how you control a plotting program. All right. And if you've managed to get through all the previous ones, you can have, you should think about what technology those tools are built on, and that'll determine a lot about how they behave. If they're built on HTML, they're going to be great on a web page, not going to be great at SVG usually. If they're built on OpenGL, WebGL, these are going to be great at doing 3D. They're not going to be doing great at axes. Because in OpenGL and Axis, you're drawing it glyph by glyph, character by character, and putting it in 3D space. It's awkward. So it's not natural. Those things are supernatural in the other one. I can't say that, but anyway, each of these technologies makes certain things very easy, very powerful, and everything else hard. So it depends a lot. And if you, for instance, chose a toolkit based on Qt, that's great when you're building a Qt app. You want the same thing to appear on the web, it's not great at all. So these are going to have many, many implications. And then there's kind of a meta technology is, if you build on one of these three core libraries, you inherit all of its technology choices. So if you learn that about something, immediately you can reason about that library. And that helps you make sense to the dozens of libraries you might find in your category. All right, and then this kind of starts to veer away from visualization. There's a core thing that is plotting or graphing or visualizing, but then there are different categories that are covered by PyViz, and they're a little bit away from that. One is color mapping. This is a specialized set of tools that kind of plugs into the other ones. If you've got a number from 0 to 1,000, how does that translate to a color? And that matters a lot for science. If that's your thing, go for it. Rendering tables is visualization adjacent. A table is a visualization, and often you want to pair those. So there's a section on that. And then dashboarding starts to veer into building applications, but it also is just a little slider underneath your plot that lets you vary a parameter. And so it starts out right around Viz, and then eventually turns into a website. So we try to cover that a little bit in the site. All right, it comes down to this. So when you're trying to choose a library, first thing you can do is use matplotlib. It's probably fine. But really, if you've got anything that's not really well covered by matplotlib, think there's probably a better way to do it. There's probably a better way to do the one thing I'm doing, and it's probably not what my buddy's using, because he's got his own problems. I got my problems, he's got his problems. They're different, probably. And don't be tempted by how flashy the SciViz stuff is unless you're doing SciViz. If you're simulating meshes on solving PDEs, great, do that. Otherwise, you're probably InfoViz. Do you plot 1D arrays, like what would be in a pandas column? Great, you can do InfoViz. If you need multiple or ND arrays, multidimensional arrays, that's a whole other category, and then your choices are much, much fewer. As always, matplotlib, also these three. HVplot comes from my group. Everything else is other groups. Do you have big data? Data Shader plugs into all these other libraries. MPL is matplotlib, again, from my group. Do you need control? If you are submitting a paper to Nature, do you need it to follow Nature style exactly? Matplotlib is what you use. Interactive, though, matplotlib is technically interactive. It predates the even trying to be interactive, and it's been patched on. It works, but it's not great. All the JS-based tools are much, much better. Do you want convenience? HVplot is one example of what emerged as a standard, which is pandas.plot. Pandas.plot now supports pandas.plot with matplotlib, pandas.plot with bokeh, pandas.plot with HoloViz, same syntax, 3 different ways to render it. And then the same thing is, you can do dask.plot, and it's basically the same syntax. So that's one API you can learn, and you get access to dozens of tools. So that's a little plug. I think you probably should, if you have no opinion, learn that one, because you'll be able to use lots of tools that way. And then after that, if you still have many libraries to choose from, well, lucky you, then it's kind of arbitrary. You can pick by how popular they are, and that's a proxy for whether it's going to have community, whether there are good docs, whether AI will support it. AI will support it if it's popular. If it's not popular, you're going to have to go out of your way to make AI support it by setting up an MCP server, as in the previous talk. There are plenty of them available per library to fill in the fact that that library doesn't have 2 billion examples on the web. So the more popular it is, the better the web is going to be for feeding into LLMs, the better their answers will be. So that even if another tool is better, your results from, if you're using AI, might not be better. So, and then you can think about features, but that's way down the list. You're probably not going to get there because these other decisions will make it for you before that. All right, wrapping up. That QR code leads to this talk, and when you see if you see a plot you like, click on it. It'll point you to something that may or may not be useful, but which is where I got that image. pyviz.org, completely open community site. Please make submissions. This talk is the same. That link is the same as this. I wrote a lot of words about this, but it was back in 2018. So if I say things that sort of make sense, but you want to understand them, it's all in this blog. It is dated, but the world hasn't changed that much. It won't mention AI, but everything else is still true. And then if you care about what I do, that's in this particular link. Thank you very much.
Nice. So I figured I would pick my favorite question out of all the ones that were submitted, so I'm going to hit you with this question.
Okay.
Do you see Python Viz falling out of favor now that AI can generate a beautiful pure HTML with React visualizations on the fly?
Yes.
Short answer.
So it depends on the situation, but I think that is a perfectly good answer for people who don't. Used to be, if you wanted to make a JS, HTML, viz, but you didn't know those languages, you couldn't. Now you can. So you can stay in Python your whole life. You can ask AI to give you a JavaScript rendering of it using whatever JavaScript framework you want and just have that happen. It'll work. It's great. So on a one-off, that's a great idea. I don't recommend it as a workflow for how you do your work every day. I think you do need to learn a library and like live with it and understand its quirks. But to get one great-looking plot, 100% do it.
Nice. All right. Well, thanks, James.
All right.
Be around.
I'm around.
Hit him with all your data visualization questions.